and for any other students attending high school who would be interested.
Sure.
Okay, so could you please introduce yourself?
Yeah, so my name is Mark Edelen. I'm a professor of engineering at Howard Community College, and I'm the chair of the engineering and technology department.
John? Okay. Sorry.
Yeah. So what are your areas of expertise in your studies?
For me personally, or
Yeah, for me personally.
okay, so my personal background is in mechanical engineering. So I got my bachelor's and master's degrees from University of Maryland, College Park in mechanical engineering. I also did some postgraduate work at Johns Hopkins, also in mechanical engineering. The specific areas that I have expertise in are robotics, structural analysis, artificial intelligence, really in the context of robotics. And then in recent years, I've gotten much more involved in 3D printing and additive manufacturing, which is actually now a program at Howard Community College. It's separate from the engineering program, but I've been teaching courses in that area as well. So those are the things that I consider to be my areas of expertise.
Okay. What are some of the more interesting projects that you've worked on in your career? So we've read that you've done work on submarines, aircraft radars, even mail machines. So just anything.
Oh man, you guys have studied up on me. Yeah, you are correct. Prior to teaching, I worked for 7 years at Northrop Grumman as a mechanical engineer, and worked on a variety of really interesting projects there. And yes, so I worked on structural analysis of components that go into military aircraft, radar, particular military radar, best-selling kind of items, at least in this area. For a few years, I worked on a mail sorting system. In fact, most of the mail that you receive today, probably 95% of it, goes through a giant mail sorting machine that Northrop Grumman designed for the U.S. Postal Service several years ago, and now they're all over the country. So there's only 2 or 3 of them in Maryland, but that's enough to sort all of the mail that everyone in Maryland receives, basically. So any piece of mail that has a barcode on it that was not handwritten by a person goes through this machine, and it's about the size of a football field, and it's 30 feet tall and has thousands of parts, lots of moving parts. Picture, conveyor belts and mail trays, moving in all directions on multiple different levels. It was a really fun project if you're into like automation and like assembly line type automation, which I've always found fascinating when I was a high school student. It's like that type of thing. And then for a few years, I worked on designing submarine components, which was also really awesome. So one of Northrop Grumman's departments is called Undersea Systems. And so they design both manned and unmanned submersibles. The manned submersible that I worked on was called the Advanced Steel Delivery System. So it delivered Navy SEALs to to shallow waters to do like covert ops. So it was like a mini submarine that could hold about 10 Navy SEAls. So I designed and analyzed some of the structural components for that. And then I also worked on some of the unmanned submersibles, which are basically mine hunters. So they swim around autonomously, searching for underwater landmines using sonar. So that's a few projects that I've worked on as an engineer before I went into teaching.
Can you tell us about HCC's 3D Innovation Hub?
Actually, so the 3D Innovation Hub was actually shut down a few months ago, which was kind of sad. I think the reason why is that HCC didn't have the resources in terms of manpower to commit to like running it really. It needed like a full-time person, at least one full-time person to operate that hub. So that doesn't exist anymore. But the good news is that the the most advanced like 3D printing capabilities that we have on campus are in the engineering lab anyway. They were not in the 3D hub. So the engineering lab has the best and newest printers. And so as the 3D hub was shutting down, our additive manufacturing program was starting up. And we already had quite a few printers for the engineering program, but we got even more and even more expensive and even better ones for the additive manufacturing program. So we have a nice array of printers now, and they're all in the engineering lab, which I love because that's the lab that I manage and control. So I get to play with them anytime I want, and all the students do too.
All right, yeah, thank you. We're wondering, how did you get into teaching?
Even when I was in grad school, I thought that I would really enjoy teaching. I think I discovered that by being a teaching assistant, by being a TA while I was in grad school, and just helping my classmates. You know, like doing homework together in college with other people. I just enjoyed helping other students when I was still a student. But I didn't want to teach. I didn't want to teach college when I was, 21 or 22. Because I wanted to get some industry experience first. So I kind of wanted to earn the right to talk about engineering or to teach engineering by doing engineering first. So I actually did the job for a few years, and then I decided, okay, maybe now it's time to go teach it now that I know what I'm talking about.
So we know there's a lot of conventional jobs for engineering degrees, like becoming an engineer for a corporation or the government, or getting into education and teaching engineering. So what other unexpected jobs do you think an engineering degree would apply to besides engineering?
Well, one kind of class job that's very common in this area is consulting. There's a lot of companies around here, like Booz Allen is a big one. They hire a lot of engineers just to be consultants, and so those engineers, they don't. I mean, they're still doing engineering, but a lot of what they're doing is really giving advice to engineering firms. So Booz Allen doesn't really consider themselves to be an engineering firm, but they provide consulting to many other engineering firms in the area. And so I know several engineers who I graduated with, who they just do consulting work, and I'll tell you what, they make a lot of money doing it. They make good. I mean, all engineers make good money, but consultants in particular make good money. So that's one area. Another area that a lot of engineers don't think about is sales. So a sales engineer. If you're good with people and you have a little bit of like a business sense, and obviously you have the technical background, if you're an engineer, then you can sell. You can become a sales engineer where you're selling a product, or it might be software or hardware. And because those salespeople need to have the technical chops to know what they're talking about, right? When a potential customer asks you a technical question, if the engineer is answering the question, then that's a good thing. So a sales engineer is one. A lot of engineers make great businessmen. Like you might not know this, but I think it's like 40% of the Fortune 500 CEOs have engineering degrees as their first degree. It's even a higher percentage than CEOs that have MBAs, which is kind of shocking. Like you'd think they would almost all have MBAs, but engineers make really good businessmen and good leaders of corporations because they are really good at solving problems. Like that's fundamentally what engineers are good at, is solving hard problems and not giving up when a problem gets hard. And that's a really valuable skill to any company. So that's another job kind of opportunity or career path that you might not think about.
Sounds great. I mean, we were asking about like the jobs of once students get out of college, but what about like internship opportunities for students while they're in college? What advice would you have on that, and what sort of opportunities are out there?
Yeah, well, first of all, I would highly encourage anyone to do an internship as early as possible. And it almost doesn't matter where. Like getting your first position is the hardest one to get. But having any relevant experience on your resume, even if it's just a summer internship, is so important. It makes it that much easier to get the second one, and that much easier to get the third one. And then if you have a couple things in your resume like that, by the time you graduate, it makes it so much easier to get a full-time position. Just the fact that you have any real-world experience in an engineering type of role. I mean, in this area, there's a lot of companies hiring interns. I know Northrop does. A lot of the defense contractors do, like Raytheon, and I think Boeing might even have a site locally here. Another really good opportunity, it's not exactly an internship, but a lot of colleges offer, they're called REUs, research experiences for undergraduates. It's usually a summer program for like 8 or 10 weeks. You get paid. Sometimes it's residential, but you're basically doing research at a university, in a university lab. And so that's also a really good experience. That's not exactly an internship because it's not usually an industry, but it is, real world hands-on experience. So an REU is a good thing to look into. But an internship with a company is also extremely valuable.
Yeah, thank you. How many courses do you teach, and what is the student favorite?
What is the student favorite? Was that the second part of your question?
Yes.
Okay, I'll think about that while I'm answering the first part. I teach, I mean, because I'm department chair, I only teach 2 courses per semester usually. But over the past few years, I've taught, I don't know, 8 or 10 different courses. So like intro to engineering, statics, mechanics of materials, dynamics, a course called engineering design with CAD, intro to MATLAB. I've taught a course called intro to additive manufacturing. I'm teaching a course right now. It's called 3D printing, 3D design and fabrication. It's like the capstone course in the additive manufacturing program. Yeah, so that maybe that's not a comprehensive list, but I've taught almost all the courses that a mechanical or civil or aerospace engineer would take at HCC. The student favorite, it's tough because it really depends on the student, obviously, but I will say that the Intro to MATLAB course is a course that many students will come back to me later, like years later, and say, that was the course that helped me the most, like in my future classes. So I don't know if it's their favorite while they're taking it, but they take it and then they transfer to College Park or they transfer to UMBC or somewhere, and then they use MATLAB in like every single engineering class. And they are so happy that they took this class so they knew how to use MATLAB. And so, yeah, a lot of students have come back and said, okay, that class was, so helpful. I'm really glad I took that class. So maybe that's a favorite in retrospect for a lot of students, I think.
Going along with that question or answer, what programs would you recommend high school students learn before entering college? So you mentioned MATLAB. Would you also include like Java, SolidWorks, any other specific programs?
Yeah, I'll start with one that might shock you, but because it might seem too simple, but Excel. I mean, I'm shocked by how many freshmen don't know how to use Excel very well. And Excel is a more powerful tool than people think, and more, including for engineers. So Excel is one. MATLAB is a great one. It's not necessary, I don't think, to know it before you start college, but certainly wouldn't hurt. A programming language. I don't think it's critical which one, but like Python or Java are good choices. Yes, a CAD program. Again, I don't think it matters that much which one it is as your first one, but SolidWorks is definitely a good choice, but it's not free. Fusion 360 is a good choice that is free. And there's many other CAD programs that are also free and high quality. But with most of these things, like a programming language or a CAD tool, learning the first one is the hardest. Learning your second and third and fourth, it just gets easier and easier and easier. But the important thing, I think, is to get over the hump of learning your first one, like your first programming language, your first CAD software. Just get that under your belt, have that on your resume. And once you start to learn other ones, it just gets easier as you go. So those are probably the main ones I would highlight. Yeah, I think that's it.
Thank you. So we read about your graduate research on robotic swarm dynamics. And then we were just thinking because I recently read an article about engineers researching bee swarming, like when they are switching hives. And then there's a lot of interest in like utilizing their like swarming techniques in terms of make strengthening buildings. So I was just wondering if like that's the sort of research that you did, or you did something totally different.
Yeah, mine was not based on the behavior of bees in particular. Mine was based on the behavior of ants and termites, and the way that they forage for food. Like collectively, they forage and find a food source, and build like self-reinforcing paths to that food, so that other ants or other termites can find that food source. And that's relevant to robotics in things like search and rescue. So if you had like a swarm of search and rescue robots, they might use a similar algorithm or similar behavior to find like a victim and alert other robots or other humans for that matter to where that victim is. I'm not familiar with the bee swarm in particular, but there's a lot of biologically inspired swarm robotics applications that are based on flocks of birds, like schools of fish, various types of swarms. It's fascinating. One of the cool things about bees and other like flying insects that's cool is that they're like robust in the sense that they can run into things and each other, and they're just fine, right? They just keep flying. They recover. They run into things all the time. Like if you watch slow motion of like a beehive, they're always running into each other, but it's just okay. Like they just keep flying. It doesn't hurt them. They don't break, So one of the ideas in swarm robotics is let's just make these, like if you picture a swarm of like UAVs, let's just make them so that they can run into each other and it's okay. Like there's one school of thought that says let's make them optimal so they never run into each other. That's cool, but it's really computationally expensive and hard to do. But then there's another school of thought that says like let's make them like bees where they're really good at flying, but they still make mistakes and they can hit things and they just kind of bounce off and it's okay. So maybe we should make our robots more like that. So I'd love to do a project like that at HTC, by the way. And we have a UAV lab that we've been setting up for the past couple of years so that we can do some of these indoor like UAV projects in our lab. So I think that's coming soon. That's
awesome. What would you recommend students interested in engineering continue in STEM education at the college level and beyond? So so how would you recommend students do that?
How would I recommend that they do what?
How would you recommend students interested in engineering continue in STEM education at the college level and beyond?
Do you mean how, like, in terms of pursuing their own personal education?
Yes. Like, I think for a lot of high school students, they're not really sure what like how they want to pursue, like what major to pursue, or like what to do after undergrad. So like, what's your advice on that?
Oh, okay, okay. After undergrad. Um, I don't know, there's a lot of ways to answer that question. I mean, there's no one right path. It's very much dependent on the person and what they are oriented toward. And so I think it just comes down to like learning who you are. As you go through your undergrad experience, you're going to learn who you are and what motivates you. Like some people love like academia, and they love that environment. They love like the research side. And if that's you, and you'll probably discover that as an undergrad, then you probably just jump straight into grad school, right? Because you love academia, and that's fine. Like some people love that. I was one of those people. Some people don't really love that. They just want to like start designing stuff and start building stuff and like making money. That's fine too. Then you just go get a job. Then start working. And some people kind of do both. Like they start working while doing grad school. So I don't know. I think it's about learning who you are and like what excites you about the field, and then just pursuing that. There's a lot of doors that will be open to you once you get your bachelor's in engineering, and I think they're all good doors. Like, there's a lot of good paths to take from there. That one of the most common questions is like, should I get my master's degree right away, or should I like wait and work for a while and then maybe go back to school for the master's degree? And on that question, I personally think it's better to just get it right away, because the farther you get in life, the less time you're going to have available to like take classes at night. People do it all the time, so it can certainly be done, but I think it's better to just get, if you know you want to get a master's degree, just get it immediately after your bachelor's. In fact, what I did, and a lot of colleges have this, I know College Park has it, they have like a 5-year bachelor's plus master's. So you can get both the bachelor's and the master's in 5 years. It's not easy, but it's great when you're done, because it only took you 5 years and you have them both. And you get to like double count some classes. So you take like a 600, 500 level class. It counts towards your bachelor's degree, and it counts towards your master's degree. So it's more efficient than doing them separately.
Yeah, that's great. What opportunities do you try to provide at HCC for students trying to get into a STEM field?
Many of them. I mean, one of the things we launched maybe 3 or 4 years ago is an undergraduate research program. So students at HCC can do research while they're still at HCC with a faculty mentor. So it's usually a small group of students, like 4 students with 1 faculty member doing a research project that's like original, lab-based research. I'm not talking about like going to the library or like researching stuff online. I'm talking about doing an experiment in the lab. So that's really cool. That's a cool program that is available to any STEM major, not just engineers. We do a lot of like transfer fairs and like inviting transfer institutions to come to HCC to recruit our students. Like for example, almost all of the College Park engineering departments send people to HCC to try to recruit our students. So we do things like that. And more fundamentally, we try to make sure that all of our engineering classes align with the same classes at local colleges, like local universities. So, all of the courses line up, they all transfer. Like you're not we don't want our students to be wasting time or wasting credits at HTC. So we make sure that our curriculum aligns with the curriculum at engineering schools locally. I don't know if that answers the question, but
Yeah, that's very helpful. I think for a lot of the high school students, like that helps us know like what we're doing, and that helps us understand like how if we wanted to transfer from one school to another, or if we want to take certain classes at ACC. It's really helpful.
cool.
We have a really big question for you. So, where do you think technology is heading in the next decade? So we know that technology is moving faster and faster. So the internet like really developed in the 2000s. Smartphones from 2010 to now. Where do you think the next decade is gonna go?
Oh man, that is a big question. I guess I'll pick two topics. One is artificial intelligence is becoming more and more pervasive, and influencing all different parts of our lives, which is both good and scary. That's going to continue, and I think that's going to be a big topic for the next decade. And then the other one is additive manufacturing. I know I keep mentioning it, but it's having a greater and greater impact on industry and just the way parts are made across all industries. I mean, there's big companies now like GE and Boeing and companies like that who are putting 3D printed parts onto aircraft and onto jets and stuff that we didn't see 5 years ago. So, and even automakers, like major automakers now are 3D printing parts to put on like regular vehicles. So that's really cool. So manufacturing is changing, and I think will change a lot in the next 10 years, specifically with metal parts. That's what has changed a lot recently is metal parts being 3D printed, and they're good enough to replace metal parts made different ways, the old-fashioned ways.
All right, yeah, that's really interesting. Last question we have, do you have any other advice for students? Just anything at all?
Advice for students. Let's see. Do you want it geared toward high school students or college students, or it doesn't matter?
It doesn't really matter.
I know this is hard, but like, I don't know if this is fair advice, but to try to not be like obsessively like grade focused or like grade motivated, like that can, like I know things are competitive and like you're trying to get into the college you want to get into, so you have to care about grades. But if you take that too far, it can suck like all the joy out of learning. Like it can just ruin it, right? And I know like there's gonna be classes that you hate. I know that, and that's just part of life. Like so, maybe that's part of the advice is look, there's just gonna be some classes and teachers that are not very good, and you just have to buckle down and like get through that. But like hopefully there's gonna be some classes that you really enjoy. And so I would say like enjoy those without being like too like hyper focused on what is my grade, you know? I don't know if that makes sense, but
No, that totally makes sense. I think some of the members of the team had like a philosophical question about it. It's like, or it might have been with another group of friends, but it's just you're so oriented on the return of a grade, and are you really doing it for the content of the class, or is it just the letter that comes back?
yeah, right. And it's really hard. I mean, it's hard to not focus on the grade. I realize that. I remember being in your shoes. I think that advice is probably more. It's easier to follow that advice, I think, in college than it is in high school. Because in college, I think in high school, you're GPA matters so much that there's more pressure on it. Your GPA still matters in college, but it doesn't matter nearly as much. Like in college, like if you get a bachelor's in engineering and you got like a 3.7 GPA versus a 3.4 GPA, like it doesn't matter. Like you're still gonna get the job, you know. Like it still matters, but it just doesn't matter as much as in high school, where I know that it matters a lot when you're trying to get into colleges and get scholarships and things like that. So once you get over that hurdle and you like get into college, like take a breath and like it's okay to get a B. Like, you know, like try to care about the content of the class to the extent that you can.
I guess that goes hand in hand with learning more about yourself throughout college. You can start
Right.
relaxing a little bit on the grade. You know, do you really enjoy the content of the class that you're actually taking?
Right. Right.
It all ties into it.
And I have to say this because I'm a professor, but if you have to choose between like academic integrity and like getting a worse grade, like just get the worst grade, you know, like keep your academic integrity and get the slightly worse grade, because what happens to people, and you guys know this already, I'm sure, like you don't have time to do the assignment, and so it's tempting to do something dishonest to get the assignment done on time and get it in on time, right? That temptation will still continue in college, but I believe that like people who practice honesty and integrity as students are more likely to have integrity as engineers. And like we need engineers who are not gonna like fake it or like cut corners when they get their job. But if they've been doing that their whole education, they'll probably keep doing it like in the workplace, you know? And so that's more like an ethical advice, I guess.
Yeah, thank you so much.
Yeah,
Yeah,
absolutely.